Welcome to MvDad.com for a simple, stable structural solutions. In this session, we will discuss about. In this session, we will discuss about the beam. Just click on any element, one can get the submeaning. Before that, I want to explain to you these colors, different colors for different beams. They mention like this. Simply support other continuous B1, B3. The color indicates the end conditions of the beam. B2 is continuous, other simply supported. In similar way, all the colors are there. That means from the plan itself, one can understand the end conditions of the beam. Now we will coming back to the beam. Just click on the beam, detail calculations. We selected floor 1, beam B3, simply support, other continuous. B3, floor 1, left support simple, right support continuous. Beam self weight and wall loading detail calculations for dead load. Same way for live load. For frame analysis, fixed end moment calculations. All these detailed calculations, formulas are explained which we require for the 3D analysis, 3D frame analysis. And this B3, we are getting the load from the self-weight B3 slab S1, and that loading full detail calculation, and the other side slab S3. Summation of A plus B, fixed end moments. It is bifurcated in two parts, dead load and live load, which we require for the earthquake analysis. Same way for the section beam 4, because this is in the chain B3 and B4. To evaluate the to do the frame analysis, we need this full chain calculation. Same, yeah. Here we got the distribution factor. This is 3D analysis, so we have considered the column in this also. At the C4, C4, B3, and at the midsection B3, C5, C5, B4. Then moment distribution by three methods: max and min, min and max, max max, min and max. For the dead load cases and the live load cases. That moment, then shear, which we calculated in the tabular format, so that one can understand. And here is the tabular format of the total frame analysis, frame movements. And maximum of these above 3, the values are this 84.1, 104, 104, and 42.1. We will see the values on the shear force and bending moment diagram also. Now shear, we calculation, simple, continuous, continuous, simple, as per the loading. Now this we calculated the frame and finite element method calculation for the graphic, and the main intention to get the bending moment at the face of the column. For that, this detailed calculation by procedure finite element method, which we have tried our level best to show in the tabular format. This is lengthy, but this is the essence of our software to save the steel. Here we got the shear force and bending moment diagram. This is the shear force, this is bending moment for the B3 which we have selected. And according to that, bending moment at the face of the column, bending moment, maximum bending moment 52.59, which one is this, at the center, distance 3 meters from the same, at the end 104.5, and the face of the column, it comes under around 89 point something. Now these values we are going to use for the steel calculation and section calculation. B3 is a T-beam. From bottom side it comes the slab 1 and the upper side it is the slab 3. As per the T-beam, we evaluated the simple and continuous detailed calculation, pitch, percentage of steel assumed 0.26, main steel calculation as per the IS code, as per IS 13920 class 6.21, we require minimum dimensions 0.26% minimum percentage of steel, and for IS 456 it required 0.12%. So by keeping that in mind, 13920, we are calculating the main steel as per the 0.26%. Then here it comes the maximum of these three, it is 622, number of bars 16 mm one layer and 12 mm second layer, both 2 to total 4 number of bars. ST provided, single unit for beam. Then top compressive steel calculated, top tensile steel at the support because of the continuity. Check for the width of the beam, minimum width, number of bars, N1, N2, D1, D2, required is 168 mm, whereas we have provided 200 mm, hence it is safe, no need to revise the section. Check for effective cover required as per the formula, it is 36, 38, whereas we have provided 40, then it is safe. Now ST required, minimum percentage of steel, it comes provided it is 0.87%. Shear and for the transfer to the column load that we have calculated at left support 81.45 dead load, live load 16.2, maximum summation of dead load plus live load, then ultimate is 1.5 times, it is 146.475 at the left support and at the right support. Now shear check, this is as per the class 22.6.2, detailed calculation is there, number of cases, compute shear resistance of concrete, shear resistance of section with alternate bend bars, shear resistance of RC member with minimum stirrups, same way design of steel strap spacing which we have calculated, 2 legged stirrups at dia at 270 mm center to center, development length, it is okay for 90 degree bent of bars. Check for deflection, D required is 600, D effective is 350, hence revised depth. Revised effective depth is 610. The sectional size is 650. Again, as per IS code 139201933, all the parameters which we have verified, rechecked, and accordingly implemented. Quantity cement concrete in that particular beam, weight of wall on the beam which we require for the earthquake analysis, steel weight for main steel and secondary steel, total steel, main steel is 36, secondary steel 49, steel of steel weight. Now this is the final result. B3, floor 1, left simple supported, right continuous as per the IS 456 223.2.1. LX is less than 10 meter, main steel is 415, secondary 415, concrete M20 200 by width is 200, depth is 650, 6 meter, length quantity 0.78 cubic meter. The top steel at the corner left support, 2 number of bars 12 mm dia, 4 bars 16 mm. At center at the top, 2 number of bars 12 mm. At the right support same way. At bottom, at left support, 2 number of bars 20 mm dia and 1 bar 12 mm. At main mid span, at bottom, 2 number of 20 mm dia, 1 bar 12 mm. Same way at the right support. And accordingly the total calculation steel weight we have calculated. Loads on column 146.475, 146.475 at the left support and right support respectively. In this we had discussed about the detailed calculation of the beam as per the 3D frame analysis. Now we will see its shear force and bending moment diagram for the B3 floor 1. Floor 1 B3. Floor 1 B3. Values which we have to check it, what we got, and here we are displaying. This is dead load, this is max and min. 84.5, 52, 104, 104, same way. And one can check dead load shear force. This is the dead load for max min. It comes the max min. It is working, not ultimate. Now we will see the schedule of steel in this same tabular format as we explained it for slab and footing. It is the same. One can go through the table for each and every floor. One can get the result for terrace. Now we will see the steel drawing. Here number of parts are mentioned. One can go through it and verify it. I hope clarified about the beam design. If any doubt, please contact me on email or WhatsApp. Thank you.